Right now, we are at the Johnson Space Center in Houston, Texas, standing inside the Space Environment Simulation Laboratory in front of Chamber A. Chamber A, actually the largest thermal vacuum chamber in the world.
It has a 40-foot diameter door, which weighs 40 tons. The door is hydraulically operated, and it's perfectly balanced. It's so balanced that two people can push against the door and move it.
Chamber A is currently undergoing upgrades so that it can house the largest satellite, the James Webb Space Telescope, in its testing for the space environment.
So for the last 3 years, we've been remodeling the interior of the chamber so it's acceptable for the cleanliness and the temperature that James Webb needs.
Some of the things we've done is we've upgraded our helium system, we've upgraded our liquid nitrogen system, as well as updating our airflow management system. With all these upgrades put together, we can now reach temperatures that no one's ever really been able to reach before.
Where we're actually going is 11 Kelvin, which is 11 degrees Celsius, essentially, above absolute zero. So the absolute coldest that we can get to is possible, not even really possible.
What we get out of a thermal vacuum chamber test is that we can evaluate whether or not the spacecraft, all its systems perform like they're supposed to perform once they're out into space.
All the air inside the chamber right now at ambient temperature weighs about as much as 12.5 Volkswagen Beetles, so about 25 tons. By the time you remove all the air and all the molecules out, all the mass inside the chamber is the equivalent of about half a staple. That's very rough, but it kind of just to put it in perspective of what we're doing. Chamber A was originally built as a simulation for the Apollo mission to test the Apollo capsule.
Back for Apollo, the chamber had to be ready to have people put into the chamber inside their vehicle. So it was man-rated, and it still is man-rated, but we obviously don't need to put people on the telescope. So that's not so much of a concern for us anymore. What is a concern is that the telescope has to have a very clean environment since it's an optical telescope.
Actually, right where I'm standing right now, several feet back and all the way to the chamber and all the way to both sides of the high bay, we're going to be installing a very large clean room that will allow engineers and technicians to work on the satellite as they're prepping it to go into the chamber.
During the final flight test of James Webb, it will be in the chamber for, we're anticipating 90 days. The first roughly 30 of those days, we will not be doing anything more than cooling it down because it's just got to radiate all of its heat out to those cold shroud walls. It will take a long time for it to drift down to its eventual operating temperature. Then for the next period of weeks, they'll be running tests on the instrumentation systems. And at the end, will take us about another 2.5, 3 weeks to warm it back up so that we can bring it back out into the Houston humidity. Chamber A is now the most capable thermal vacuum chamber on the planet.